Hello everyone, my name is Natsuki. I will be your instructor today. The term inverter is often heard in reference to home appliances. Do you know what this term means? Simply put, an inverter is a device that controls the rotational speed of a motor. Inverter circuits and devices are used in equipment that move machines with motors. This is why inverters are used in a wide range of applications throughout the world, ranging from motor-driven home appliances to industrial machinery in the heavy electric appliance sector. In part 1 of this video, we will learn what an inverter is and see application examples and the benefits of energy savings. After this, I will describe their ability to enhance comfort and controllability. In part 2, we will learn how inverters work and see some actual energy-saving examples using inverters. Moreover, part 3 introduces general types of inverters, and part 4, Fuji Electric's inverters. Let's start by taking a look at what kind of equipment inverters are being used in throughout the world. Inverters are actually used in places that are very familiar to us, and even in places like these. For example, they are used in elevators, air conditioning systems, running machines, CT scanners, and car washing machines. Inverters are installed in airport belt conveyors, sewage pumps, harbour cranes, and tunnel excavators. In factories, they are used in a wide variety of production equipment, including steel rolling equipment, metal processing machines, printing and packaging machines, textile machines, and semiconductor manufacturing equipment. In addition, inverter technology is being applied and used in wind power generation, solar power generation, and electric vehicles. As you can see, inverters play an important role behind the scenes supporting people's lives. The benefits of using an inverter is that you can freely adjust the speed of the motor and the time required to change the motor speed. It is possible to freely control not only the rotational speed of the motor, but also the time it takes to change the speed from 0 to the maximum speed and from the maximum speed to 0. Many facilities use inverters to reduce motor rotational speed to save energy and reduce the load on equipment. They also improve comfort and control by changing the rotational speed slowly to enhance ride comfort, or by changing the speed rapidly to speed up the transport of cargo by cranes. At the same time, there are some applications where no energy-saving effects can be achieved at all. These include engine testing machines, where the motor speed is increased to evaluate the durability of automobile engines. In this presentation, I will introduce you to the typical benefits of using inverters. 1. Energy savings, and 2. Enhanced comfort and controllability. To begin, we will look at energy saving as the benefit of using inverters based on some inverter application examples. So for starters, let's look at an air conditioner as an example. Air conditioners have a motor in the compressor unit that produces cold air. An inverter is used to control the rotational speed of the compressor's motor. In inverterless air conditioners, when the room temperature rises above the set temperature of the thermostat, the compressor's motor is activated to run at full speed to lower the room temperature. The motor will stop only when the room temperature falls below the set temperature. By repeating this process, the room temperature is controlled within a certain temperature range. As a result, the motor is always running at full power when activated. If the time spent repeatedly starting and stopping the motor is equal, the motor will occupy about 50% of the consumed energy as an average. On the other hand, inverter-equipped air conditioners can smoothly and precisely control the rotational speed of the motor, so that the rotational speed is gradually reduced as the room temperature approaches the set temperature. It will then maintain this reduced speed when it is near the set temperature. In general, the torque required to rotate the motor will vary in proportion to the square of the motor's rotational speed. In addition, the motor output will be proportional to the cube of the motor's rotational speed. This property is called the square law speed load characteristic. Therefore, if we assume that the set temperature can be maintained at 50% of the rotational speed, the motor output required would be the cube of the motor's rotational speed, which is 12.5%. As a result, an inverter-equipped air conditioner can consume less energy than an inverterless air conditioner by rotating the motor only as much as is necessary to maintain the room temperature. This type of smooth rotational speed control is the key to energy savings. In addition, inverter-equipped air conditioners are said to reduce stress on the motor and the entire system by more than 6 times compared to air conditioners that do not use inverters. This is because the inverter eliminates the abrupt starting and stopping of the motor. Next, let's take a look at the inverter application for pumps, such as those for pumping water. In inverterless pumps, the flow rate is adjusted by a valve. However, with this type of pump, the motor must run at full speed even when only a small amount of flow is needed. With an inverter-equipped pump, the valve is left fully open and the motor's rotational speed is controlled by the inverter. If a small flow is needed, the motor's rotational speed can be reduced accordingly. If more flow is needed, the motor's rotational speed can simply be increased. This type of system allows us to save energy by eliminating wasted energy. By the way, in equipment that possesses the square law speed load characteristic that I explained earlier, the power consumption of the motor is generally proportional to the cube of the motor's rotational speed. If the motor's rotational speed is reduced, its output will decrease in proportion to the cube of the speed. If the pump is operated at a rotational speed consistent with the flow rate, it can be operated using only the required energy. This is another example of how inverters help to save energy. Next, we will see application examples of how inverters can enhance comfort and controllability. For example, let's consider elevators. I assume that everyone has ridden in an elevator. Wouldn't you be surprised if the moment you got on an elevator, it suddenly started going up at high speed, and when it suddenly stopped, the force will probably make you fall down. To avoid this, elevators start off slowly, gradually increase in speed, and then slow down again when you come to a stop. This is because it is being controlled by an inverter. Belt conveyors also move slowly and gently when they start and stop in order to avoid the load from falling or being overstrained. Likewise, if port cranes are not equipped with inverters, they will carry cargo with sudden starts and stops, causing the cargo to shake and fall. By using an inverter, cargo can be carefully loaded and unloaded quickly by gradually increasing or decreasing the transport speed as necessary while monitoring the shaking of the cargo. In this way, inverters can be used to enhance the comfort and control of equipment. Now, let's take a look at how inverters work. How does an inverter change the speed of a motor? To change the motor's rotational speed, it needs to change the frequency and voltage applied to the motor. The higher the frequency, the faster the motor will run. Similarly, the lower the frequency, the slower the motor will run. This means that variable speed operation is possible by changing the frequency and voltage of the inverter. Frequency refers to the number of times the same waveform is repeated in 1 second. For example, 60 Hz means that the same waveform is repeated 60 times per second. As the frequency and voltage change, the motor's rotational speed changes along with the rotational speed of its rotating magnetic field. By precisely controlling the frequency and voltage, the current of the electric motor is stabilized and the motor can be controlled more efficiently. This means that the inverter controls the motor's rotational speed freely by manipulating the frequency and voltage. What is the mechanism that controls the frequency and voltage? Please take a look at this diagram. An inverter consists of a converter circuit, capacitor, and inverter circuit to produce AC with controllable frequency and voltage. First, the converter circuit converts the AC coming from the power supply at a certain voltage and frequency into DC. After this, the capacitor smooths and stabilizes the DC voltage by repeatedly charging and discharging. Finally, the inverter circuit converts the DC voltage back into AC at the desired frequency and voltage and applies it to operate the motor. Power semiconductor IGBTs are characterized by their high-speed switching and are used for converting the desired frequency and voltage in inverter circuits. I will explain about power semiconductors a little later. Now, despite the convenience of inverters, they can cause trouble if they are not used properly. If no measures are taken, the converter circuit in the inverter will generate harmonics, which are currents that affect the power supply. Moreover, in the inverter circuit, noise current will flow during fast IGBT switching of voltages and frequencies. This can easily cause peripheral devices to malfunction. Inverter manufacturers mitigate the effects of harmonics by incorporating a component called a DC reactor into the inverter to reduce current distortion. As for noise current, they use a component called a zero-phase reactor and adjust inverter parameter settings to block noise current. This is how we make sure that the inverters are safe to use. The following is an example of achieving energy savings with an inverter. It is based on an actual case study conducted at Fuji Electric's Suzuka factory. Huge exhaust fans are in constant operation in the painting booths of motor production lines. In the booths, inverters are used to control the speed of the exhaust fans by automatically linking to the painting process. While the operator is using the spray gun for painting, the fans run at a high speed at 60 Hz because a large amount of exhaust air is needed. When the painting work is finished and the spray gun is put back on the hook, the fans run at a low speed of 30 Hz because only a small amount of exhaust air is needed. After 10 minutes of running at low speed, the fans are programmed to automatically stop. The key to achieving energy savings is to control the fan's frequency to ensure the required exhaust volume. After equipping the painting line with inverters, energy-saving effects about 52% were achieved. Inverters are classified by circuit types and control types. Among circuit types, there are 3 kinds of inverters, including voltage inverters that output voltage, current inverters that output current, and resonant inverters. Depending on the control method, these are further classified into voltage inverters such as PAM control and PWM control types, current inverters such as PAM control and PWM control types, and resonant inverters such as series and parallel types. For the motor control inverters that I mentioned earlier, these kinds of applications use a PWM control type voltage inverter. PWM and PAM control will be introduced in another course. Next, let's take a look at Fuji Electric's inverters. Fuji Electric has been manufacturing and supplying general-purpose inverters to the world since 1976. The reliability of our product has been highly evaluated by our customers for many years, and we now have the second largest market share in Japan. They are used in a wide range of applications, from factories to air conditioning systems in commercial facilities, elevators in buildings, and railway cars. Fuji Electric produces power generation equipment to create electricity, transformers and other substation equipment to change voltages, switchboards to send and distribute electricity, inverters to use electricity freely, drive and control equipment such as motors and PLCs, and power semiconductors embedded in inverters. In other words, we are a comprehensive electrical equipment manufacturer. Based on these achievements, we have developed power electronics technologies that integrate power conversion, control, and drive technologies. Inverters operate and control motors by freely manipulating the frequencies used in power conversion. They do this by using a combination of power electronics technologies. Fuji Electric has used these technologies to become a true specialist in the field of inverters. In particular, power semiconductors, IGBTs, are core components that can be said to be the heart of inverters. Since the inverter circuit switches the voltage and frequency by repeatedly switching the electricity on and off at high speed, the faster the switching, the faster the inverter can run the motor and smoothly change the rotational speed. Power semiconductors influence the response speed and control accuracy of inverters. There are only a few inverter manufacturers in the world that can develop, manufacture and install power semiconductors as core components. Fuji Electric's power semiconductors, IGBTs, have the third largest market share in the world. Fuji Electric is utilizing its own highly reliable power semiconductors to develop inverters with even better performance. Fuji Electric's inverters are available in a wide range of lineups to accommodate various applications and performance needs. We offer a wide range of general-purpose inverters, including the compact Frenic Mini series for applications that require simple performance and features, the Frenic Ace, Mega and HVAC series for standard applications and performance, and the Frenic VG series as a premium lineup for applications that require high performance and features. Today we learned some basic knowledge about inverters. I hope this course has enabled you to understand a little about the benefits of inverters and how they support our daily lives. Thank you very much for taking this course.